Look, medulla is going to be right here, right? This is medulla. In the medulla right here, okay, they're going to see important nuclei, okay? Okay, I'll just make it like, I'll make a 4 of them. One here, and let's make this up. Okay, let's use the same color. Okay? So as you made the red. So look, and this is gonna be, this is the right side and this is the left side, okay? So look, right here, and you're gonna have another one to here, and then you're gonna have this color right here. Sorry, this is not a yellow, but we have to use a different color. Right here. Look, so basically, okay, the first neurons are located in the dorsal root ganglions, okay, and this is going upward, okay, and then, okay, they see a second order neurons, okay, and they see, okay, for this dorsal, okay, look, we call them, this one right here, okay, we call them, this is what posterior, right, or dorsal column, okay, because it's bringing this information, so it still is a dorsal, okay, it's bringing the information upward, okay. So when they go right here, okay, in the medulla, in the lower part of the medulla, they have the nuclei, okay. This red one, you see, we call them, okay, you can call them a nucleus of gracilis, okay. And then this is called, this one, this is called, let's just make this as a, okay, let's make this as a nucleus of gracilis, all right, and this is called nucleus of cutaneous, okay, this is nucleus cutaneous, okay. So as you guys know, you guys probably know already that, you know, this guy's right here, this synapse right here, okay, this the first order neurons, the synapse right here. And what is this? And same thing with this one. The cuneatus, okay, this particular cuneatus that's bringing the, okay, first order neuron, that's going to synapse at this neurons right here. And these neurons is called, okay, right here, nucleus of cuneatus. So this nucleus of, this is second order, guys, this is a second order neurons, okay. So now your second order neurons have, okay, which is located in the medulla, they have a collections of sensory informations from the T5 level and upwards, okay. And this gracilis right here, this is a nucleus of gracilis, now they have information from T6 and downwards, okay. Then as soon as when this happens, okay, you know what they do? Very important concept. I'm going to draw in different. You know what? They start crossing overs. Look, this is what happens. They start crossing overs. That's what's going to happen. And then I'm going to make a different color for this one. And this is also going to happen with this guy right here. Look. Blue right here. And then let's say, if I quickly make it a different color right here, let's say if I'm talking about, okay, if I'm bringing my information from this side, okay, let's say this is right, left side of, let's say, leg, okay, let's say this is a leg right here, bringing sensory information right here, okay, and then synapsing the dorsal root ganglions, okay, and bringing this information right here and moving upwards like this, okay, it goes up to it. And then let's say up, down here, and it goes to the gracilis here, and let's say from my hand or like my proprioceptions, all that, coming down here, okay, again, this is going to go to the dorsal root ganglia, okay, and bringing this information, okay, and go to the cuneatus, right. And look, this guy right here, bringing this gracilis is going to synapse at this neuron right here, and this guy is going to synapse at this area right here, Okay? And remember, I hope you guys are following. And after that, what is going to happen is that these guys will cross over too. So if I do crossovers right here, look, this will cross over to right here. Okay? And then same applies for this one. They do a crossover like this. They do a crossover like, see? So this process, this is crossing over. This is called decussations, okay? And this is happening in what? Lower part of the medulla, okay? And this fiber that's crossing over, we call them, okay, let me write down. We call them internal arcuate fibers. Why do we call them? The reason why we call them is because this is having the caudal medulla and it's happening within the medulla, okay? Internally it's happening, so we call them inner. And look, if you look at microscopic, if you look at it, you see it looks like arc shape, so arcuate. So that's why we call it internal arcuate fibers, okay? Look, all the way down here, okay? Anything, okay? All the way up to here, the lower part of the medulla, before the decussation, before the crossover, okay? If any lesion happens, it's going to be ipsilateral problems. Okay, it is going to be ipsilateral problems. So you have to remember this. Anything, okay, anything below the second order neurons, okay, lesions, that is going to be ipsilateral problem. And you need to remember that, okay. Then after this, okay, the decussation happens, okay. The decussation happens, okay. And what is going to happen is that once the decussation happens, I'm going to draw a different color, okay. So let's make this, this guy right here. It's bringing the information like this, okay, and goes to the pons and also midbrain, and this is also goes like this, okay, and same thing here, okay. And remember, now this concept here, right here, guys, this concept, when they cross over and when they started going up, okay, they started look like a lamina shape. What is lamina mean? Basically means they're flattened, like a band shape, okay? That is why, okay? After this, we call them a lemniscus, okay? Because it looks like more like a band shaped, okay? Or flattened shape. Before we call them a, okay, posterior column. We call them a posterior because hold this pathway, we call them a dorsal column medial lemniscus tract, okay? That's what we call them, right? Because this column, we call them because this fasciculus here, okay, they're more look like a rounded shape, okay? That's why we call them fasciculus, okay? Dorsal column, and then this lemniscus word came because after this crossing over, what happens is this fibers looks more in a flattened shape, okay? So because it looks in a flattened shape, we call them a lemniscus, okay? Now what is going to happen? That is bringing this nerve fibers to what? To, it's gonna go to the, okay, pons, and then midbrain is going to go, and it's going to keep going upwards, okay? And it's going to keep going upward until it reaches its third order neurons. And guys, where is its third order neurons are located? You have to remember that. Its third order neurons are located in a thalamus. It's located in the thalamus. And we have to talk about what is thalamus, okay? Look. Okay, let's talk about it. You see right here? Like down here, that's going to be thalamus right here, okay? And remember, I hope like you have two thalamus, right? And usually thalamus looks something like this, okay? So if I make a thalamus diagram right here, okay? Look, there's going to be two of them. One here, and let's say one here, okay? Okay, let me make this really big. Let me make a one big thalamus right here. Look, right here, there's a one thalamus right here, okay? It looks like this. And thalamus are divided into, okay, this is called anterior, this is called medial, and this lateral, okay? And lateral has a further divisions. Like one is called, okay, if I make this lateral, we call them anterior, and this is called posterior, okay? And this anterior part has a further divisions, 3 nuclei. One is called ventral anterior, ventral intermediate, and this mostly, look down here, we call them a ventral posterior, okay? And then there's one nuclei presented here, we call them a ventral posterior lateral, and then on top of this, there's also one more nuclei that is attached to this ventral posterior lateral, which is called ventral posterior medial, okay? And we're not going to go detail about that, okay? But I want to remember this. This ventral posterior lateral is very, very important because this third order neurons is this one, the ventral posterior lateral, okay? This VPL is your third order neurons, okay? That is going to receive the sensory information that is coming from this lemniscus, okay? And remember, if I say this is my thalamus, right? So like, look, this is my thalamus, right? This is my thalamus, and there's a bunch of this, another thalamus right here, okay? Like this, and there is here, what is this? There's a ventricle here, third ventricle, right? And not only that, if you guys remember, if you know this, they also have a so-called, what is this tract? Okay, let's just make this. Remember this? This is called lentiform nuclei, okay? And in between these two, lentiform nuclei and thalamus, okay, there's a bunch of actions that are going down, okay? This bunch of action that is going, this is what's called internal capsules, okay? And we'll talk about what is meant by this, okay? Remember, now this is bringing informations to, okay, let me just make this, okay, let's make this in a different, like this area, okay? And I'll just make this as, okay, I'll just make this as a VPL, just remember that, okay? VPL. And they'll bring informations and then they'll go to the information to this ventral posterior lateral, okay? Like this. Same thing here. Ventral posterior lateral, and then from here too. There's a thalamus right here, okay? Now, after that, as I said, remember guys, here what do you have? You have there's a lentiform nuclei. Same thing here too, okay? You have a lentiform nuclei right here, okay? And in between the lentiform nuclei, right? Like down here, okay, in between this lentiform nuclei and the thalamus, there's a bunch of these action fibers, okay? And this is what is called, internal capsule. It looks something like this, okay? It looks something like this. It's called internal capsules. And the reason why we call them internal capsules is because this is between them. If there's internal capsule, there has to be external too, and there is. And the externals are usually located down here, okay? This whole part is external. And this internal capsule has a further divisions, okay? This part right here, we call them a posterior. This is called xeno, and this is called anterior limb, okay? So there's a posterior limb, okay? A xeno, and then this is called a xenu, and this is called anterior limb. This ventral posterior laterals, okay? So some of these fibers right here, it goes to the posterior 1/3, okay? Posterior 1/3 of this posterior limb, okay? So let's just make this. It goes right here, okay? Sorry if it's messy, but you probably, if you're following me, you know what I'm talking about, right? It goes there, and then after that, what is going to happen? Started making of fibers like this. Look, it is going to go to fibers like this. Same thing it is here, okay? And what is this? This fibers that's coming out, these are like, bunch of fibers are going, okay? And these fibers are kind of radiating, okay? Radiating from the internal capsules of the posterior limb, okay? And these are called coronal radiata because these are bringing the sensory information to the parietal lobe. But why in the parietal lobe? Parietal lobe in the post central. So if you remember, look, if this is what it is, let's say this is, if I made this a central sulcus right here, okay? You have this area right here, okay? Which is gyra, which is called post central gyra, okay? And this post central gyra has a somatosensory informations, okay? And it's bringing those somatosensory informations and mainly to those and reporting to this, the cortex of the central nervous system, but within the post central gyri because they have the somatosensory informations, okay? So that's why you have to really, really important this, okay? And remember, the way they organize this, okay, you have to know something called somatotrophic organization, which basically means is that, okay, the way this is kind of like organized is that, any information that is coming from like your genitalia, usually that is going to be like, it's going to report it down here, around here. Okay, let's just make this quickly, okay? If I make this, okay, this is let's say this is a central sulcus right here, okay? Anything, and this is a parietal lobe here, anything like coming from somatosensory informations, okay, that is gonna, from the external genitalia, that's gonna report it here, okay? And if it's coming from like, let's say feet here, okay, legs, okay, that's how it's gonna go, okay? And then basically like down here, like neck, and then like arm and hand, okay, pharynx and the larynx, okay? So this is how it's a topographic organizations of the somatosensory informations, okay? Because this is the area where the nuclear bodies are located, okay? For example, if there's a, if some kind of like, if someone hit on your external genitalia, then this will probably bring the information like down here, because this is where it can react towards it, okay? And again, this is located in the parietal lobe, but where in the parietal lobe? The post-central gyrate, okay? And this is a very, very important concept. But now, again, look, one more concept to remember is that, look, any lesions, okay, happen, let's say it happens below the, let's say, T6 regions, okay? Then if that happens, then you're gonna get a lesions at the level and below. Ipsilateral are gonna be the problems, okay? But after the decussation, right? Let's say the problem, like right here, this happens right here, okay? Because if the lesions happen down here, after the decussations or above the decussation, then you're gonna see a contralateral problem. Because remember, this fiber is just coming from where? From the left side, right? Look, this is the left side, right? So if there's a problem here, right here, right? If there's a lesion happening here, that means there's a contralateral loss of the proprioception, touch, and fine touch will happen, okay? So again, anything above the decussation, that's a contralateral problems, okay? Contralateral loss of proprioceptions, touch, vibrations. If it's below the decussation, that's going to have ipsilateral problems, okay? And you need to remember that really well, all right? Now, there's an important test that often they do, okay? And that is called Romberg sign. And what is that? Romberg sign is basically, you're able to, they'll ask you to close your eyes, okay? And as you close your eyes, whether you're able to localize your positions of your limbs, okay? And usually, okay, right now I'm not falling because, I don't have a dorsal medial lemniscus problem yet. And I hope I don't have that ever. But if people who have the Romberg sign positive, when they close their eyes, they'll start falling, okay? Because they're not, okay, they'll start falling. That is what's, okay, because they're not aware of their positions of their limbs, okay, or their locomotor system. So because of that, okay, your test will be positive Romberg sign, okay? And that is also something that they do to examine dorsal medial lemniscus tract, okay? Now, this is something about like dorsal medial lemniscus tract, okay? And again, as I said, this is one of the really, really fast tract, okay? It contains very, very high velocity, bringing the collections of sensory informations from your, okay, peripheral and bringing to the central nervous systems, okay? So, again, these guys, okay, fine touch, 2-point discriminations, they're very, very important, okay? And you should remember, like, for instance, 1A, 1B, and also this, like, alpha and beta fibers that is carrying this sensory informations, okay, and bringing to the central nervous systems, okay? There are sending fibers that is going to bring this, information to the central nervous systems, okay? There are certain conditions that can actually damage this, your dorsal medial lemniscus tract, okay? One of them is called tape dorsalis, okay? In pathology, I'll talk more about that. And also whenever there's a folic acid or B12 deficiency, okay, that can also damage your, sensory pathway tract. But at the same time, with the folic acid or like, B12 deficiency, they can also damage the corticospinal tract as well. And we'll talk about that in pathology, okay? Or I'll talk about that in spinal cord lesions. But for now, just know this, guys. It's really, really important that, you understand this really well, all right? So I think this is all I have for you guys, all right? And I hope that I made it very clear to you guys. Thank you for watching me, and please don't forget to like, subscribe, and share the channel. Thank you, and you have a good day.